Okay, now this is the last video of the three on the transformations of functions. In this video, what we're going to do as our learning objectives is to look at solving problems that involve various functions of x where there are negatives. So we've got negative f of x, f of negative x, and finally the negative f of negative x. Now, so far the previous transformations we've done have looked at moving or translating the graph left, right, up, down. And we've also looked at stretching the graph as well in the second video. So this last video will look at the final effects that these three transformations can have on a graph. So the first key concept I'm going to go through is the negative f of x, or the negative function of x. And so again, using the animation software we've been using, we do have a graph. It's in green and that's going to stay there. And the slider currently for a is at 1. And as it slides towards -1, that is going to give us our negative function of x. And we're going to see what happens to that graph as we do that. So as we slide that across, the graph will change slightly and then eventually it will end up here. Now, this is a reflection in the x-axis. The graph has flipped, as some people might describe, but more accurately reflected in the x-axis, and this will happen for any function. So it doesn't matter what the graph is, it will reflect in that x-axis. If there is anything below the x-axis, that would reflect upwards to above the x-axis. But that is what we're looking at, that our x-axis becomes a mirror line under this transformation. Now, in looking for an exam question or an exam style question, this is one where we do have a function of x, that's what's on the grid currently, and we're asked to sketch the graph of the negative function of x. Now, this was not easy to do using a computer, so I have done the best that I can, and so if we was to draw the negative function of x, it would look a bit like this. It's the same, not perfect, but particularly around the region of where x is -1. But what we would have is that anything below the line goes below the x-axis will move above, and anything above would move below. And if you use certain key points and plot those first, then try and draw your curve through those points, that would give you your best possible answer. It is possible to have coordinate questions as well, but I was having to go this time at looking at the impact in a graph sketching question. The second key concept is going to look at, well, what happens if it's the negative x? So we have a function of x, we then make the x negative before the function takes place. And so on my graph here, I have got a sine curve. It is a sine curve, and I have edited it quite a bit just to move it a bit, to make this a little more obvious what it is that's happening this time. Now, the previous transformation reflected it in the x-axis. And if we go through this video here and make a negative to make the value of x negative, this graph now reflects in the y-axis. Because if we look at the y-axis now and the two curves that are presented, we can see the y-axis is a perfect mirror line. Admittedly, it's not central in my picture, but you can see that around that central point, we actually do have reflection in that y-axis. And so if the negative's outside the function, what happens after the functions take place, reflects in the x. If it's inside, then it will reflect in the y-axis. Now, I did look for an exam question on this and I couldn't find one before I made the video, so hopefully you can, and then you can practice out this for yourself in those types of questions. So the final key concept 3 is what happens if both things happen. If we do have a negative function of negative x, and how would that impact on our graph? So again, using the animation software, I have a quadratic graph here. I've just moved it slightly to the right. I've just transformed it slightly. And again, we're going to look at what happens if both inside and outside the bracket we have negatives. Now, as I go through this video and it does the animation, what I'm really interested in is the final result, where it ends up. And if we look in this video, you can see that it ends up in this lower left corner. Now, there are two different ways you can describe this. As we know that the negative function of x reflects in the x-axis and the function of a negative x reflects in a y-axis, when we have both negatives, both happen. So this original graph, our purple graph, has been reflected in both the x-axis and then the y-axis in either order to create our new graph. However, the other way to describe it is that a rotation of 180 degrees about the origin, or 0, 0. Then in actual fact what happens overall is a rotation effect. And so either way you describe it should be fine, but it's a little bit quicker just to describe it as an individual rotation. Again, I could not find any GCSE questions where you were asked to do this. Hopefully you'll have more luck, but that's the impact that this final transformation would have on the graph. Now overall there are 7 transformations that I've gone through. It is possible to have more than one transformation happen at the same time in a function, so be aware of that and think very carefully about how your graph will look. Hopefully these videos have been helpful on the key idea of transformations of functions and how it impacts on graphs, particularly how they look and how they change as a result. Again, thank you for watching the video, and if there's any comments you want to leave, please do so below. Thanks.